Welcome everyone. The question which is displayed on the screen, it is a question number 21 of the set 1 of the CBSE Physics 2025 question paper. Light of wavelength 640 nanometer incident on the slits in a Young's double slit experiment produces an interference pattern of fringe width 7.2 nanometer. Calculate the wavelength of the light which will be produce a pattern of fringe of width 8.1 millimeter. So for that purpose, the expression which is getting importance here, that is beta, which is called the fringe width, equal to lambda into capital D divided by 2D. Here the lambda is obviously the wavelength of the light used, and capital D is the separation between the coherent source and the screen, and 2D is the separation between two coherent sources. Okay, how the configurations, if we try to recapitulate this is the first slit and this is the second slit, and from these two are actually acting as a coherent sources. Okay, and from there the waves are coming out. Like this, and these waves wavelength and phase are same. Okay, and these two waves are interfere. Okay, then what will happen? The constructive and destructive interference will occur, and if you see on the screen, and you will see the central fringe is bright, and after that you will see the dark fringe on the both side, again bright, again dark, again bright, again dark. Okay, and you will get the equispace fringes. That means the separation between the two bright to bright and the separation between two dark to dark, which is basically referred as the fringe width, and that is expressions of the fringe width here, that is lambda d divided by 2d. Here I am repeating again, this capital D is the separation between the coherent source and the screen, and it is mainly is of the order of several meters. Okay, but the separation between the two consecutive, two side by side coherent sources, that is in between the S1 and S2, this is of the order of millimeter. So one is of the order of millimeter, another one is of the order of several meters. So I think this is understandable from this order that the light's wave property is visible under this particular circumstances, under this particular conditions. Okay, so at the first case, the wavelength is used, that is lambda 1, we can say that is 640 nanometer. When the 640 nanometer wavelength is used, and in that particular case the fringe width what we have obtained, that is 7.2 millimeter. Okay, so if I write it down the equation, that is beta 1 is equal to lambda 1 multiplied by capital D divided by 2D. Okay, what is lambda 1? Lambda 1 is equal to 640 multiplied by capital D divided by 2D. So this is equation 1. Now in the same apertures, so capital D and 2D remain same here. If you use the light of wavelength lambda 2 that we need to determine here, in this particular case the beta 2, the fringe width becomes 8.1 millimeter. Obviously if you write it down the equation, then it will be beta 2 equal to lambda 2 multiplied by capital D divided by 2D. Then lambda 2 is equal to, obviously it is 6, we have to find it out, lambda 2 and capital D divided by 2D. Okay, what is given here? It is 8.1 is given, so lambda 2 by D 2D, that is equal to, we can say 8.1. that is my equation 2. Now if I just make this thing value, if I put here, that is equal to 7.2 actually. Okay, so 640 into D divided by 2D, that is equal to 7.2. 7.2 is the value of beta 1 and 8.1 is the value of beta 2. So now if I do equation 2 divided by equation 1, then equation 2 is 8.1 divided by 7.2, and that is equal to 6 lambda 2 divided by 640. I hope you understood that. Why? Because capital D divided by 2D, these two factors are cancels out each other. So from here you have to find it out what is the value of the lambda 2. So lambda 2 is equal to 8.1 divided by 7.2 multiplied by 640. I hope I can write down this equation, and obviously you have no objections about it. 81 multiplied divided by 72 multiplied by 640. Okay, so what will happen? If I just divide this 2 by 9, it will become 9 and it will become 8. Okay, 8 and 640 cancels out and it will become 80. 80 into 9 gives you 720 millimeter. Why I have written millimeter? Because the, sorry, not millimeter, it is nanometer. It is nanometer because the wavelength that I have taken, that is nanometer. The wavelength that I have find it out is